All right, so we've got this formula here. The limit is x goes to a of x minus f of a all over x minus a. And we've been working with this formula for a couple days now. What is this the formula for? Sorry, say that again. That is the formula for the average rate of change. This is not. So the limit changes the whole. If it didn't have a limit, it would be average rate of change. With the limit, it's what? It's the slope of a curve at a point. So it's the instantaneous rate of change. Okay, so if you want to know the slope of a curve at 7, then you put a 7 here, here, and here. Or if you want to know the slope of the curve at 3, you put a 3 there, there, and there. So this is the formula for the slope of a curve at a point. It's also known as the instantaneous rate of change, and it's also known as the slope of the tangent line. Okay, there's another formula that works just like this one. So I want to give you that formula as well, because sometimes this one is used. That's the limit as h goes to 0 of f of a plus h minus f of a all over h. So these formulas are completely interchangeable. They both give the slope of a curve at a point. They both give you the instantaneous rate of change. If you use this one and you want to know the slope at 2, then you just put a 2 there and there. H is always going to 0 for this formula. Up here, x is going towards the number you care about. But here, h is always going to 0. So if you want to know the slope at 7, you put a 7 there and there. Okay, so if a question asks for the slope of a curve at a point, or asks for the slope of the tangent line, you use one of these formulas. It doesn't matter which one. Okay, so we haven't yet used this formula, so I'm going to show you one example with that happening. So we're going to have f of x equal to square root of x plus 2. And we're going to find the instantaneous rate of change. At x equals 7. Okay, so since we're finding the instantaneous rate of change, that's just another name for the slope of the curve. So we're going to use, we could use either of these formulas. This is the one we have been using, so just for practice, I'm going to have us use this one this time. Okay, so since we're finding the instantaneous rate of change at 7, that means we need to put a 7 there and there. So we're going to take the limit as h goes to 0 of f of 7 plus h minus f of 7 all over h. Okay, what does f of 7 mean? The y value at 7. And how do you find the y value at 7? Plug it into the formula, right? So that's going to be 7 plus 2, which is 9. And then the square root of 9 is 3. So this is going to be minus 3 at the end there. So I'm just filling in the minus 3 and then recopying the limit and the h. All right, so this means put 7 into the formula. So this means put 7 plus h into the formula. Over here it says put 7 into f. Here it says put 7 plus h into f. So if you put 7 plus h into f, then there's going to be a 7 plus h where the x is. So it'll end up being the square root of 7 plus h plus 2. So that's a little bit tricky there, but all I did was replace the x with 7 plus h. Because that said do that, put 7 plus h in for f. Okay, so should I try limit laws on this limit?
No.
Bottom's going to come out to 0 if you do that, right? So we have to try something else. What do you think we should try on this problem? Since it's got a square root in it, probably we're going to rationalize, right? So if you have a limit that has double fractions in it, got this fly. We've got bug problems 2 days in a row now. All right, so if I was going to try to, if I had double fractions in my limit, then I would clear the double fractions, right? If I could factor, then I would factor. But when I have a square root in my limit, a lot of times the way to go is to rationalize. So I'm going to rationalize this. So I need to multiply by the conjugate. And the conjugate is this exact thing except plus 3. So it's the square root of 7 plus h plus 2 plus 3. And then you multiply by the same thing on the bottom. Okay, so remember, don't multiply out the bottom. So we're just going to leave the bottom alone. So that's going to say h parentheses square root of 7 plus h plus 2, and then plus 3. But then you do want to FOIL out the top. So we got this times this. So that times that, the square roots cancel. So you'll just have 7 plus h plus 2. Then for the outers, it'll be plus 3 times that square root. And for the inners, it'll be minus 3 times that square root. So those will cross out, right? And then the lasts are minus 9. Okay, so that's really convenient because the 7 plus 2 is 9, and then the minus 9 makes 0. So the top is just h. And then that h will cancel with this h and just make 1. So we've got the limit, as h goes to 0, of 1 over the square root of 7 plus h plus 2 plus 3. And now we can do limit laws. So the limit of 1 is 1. The limit can go inside the square root. The limit of 7 is 7. The limit of h is 0. The limit of 2 is 2. So that'll be 7 plus 0 plus 2 in there. And then the limit of 3 is 3. And then 7 plus 2 is 9. Square root of 9 is 3. 3 plus 3 is 6. So the final answer is 1/6. Okay, so what does that mean? What is the 1/6? Yeah, Steve.
The answer to the limit is h equals 0 of f.
Yeah, good. It's the answer to this limit. And what does this limit calculate for us? Yeah, Lauren? The slope of the curve at x equals 7. So if I graphed this square root of x plus 2 at 7, the slope is 1/6. Okay. And when it asks for the slope of the curve, you can use either of these formulas. Okay. Sometimes you want to know the slope of the curve at a bunch of points. Okay, so let's say I think I got another problem here. Yeah, this is example 2. Let's say f of x equaled x squared. And let's say there was a part A that said find the slope of the curve at 1. So then we do that whole process that we just did with 1. And then there was a part B that said find the slope of the curve at 3. And so then we had to do that whole process that we just did with 3. And then there was a part C that said find the slope of the curve at -5. So then we'd have to do that whole process that we just did at -5. That would be annoying, right? Because we keep doing the same process over and over again, just with different numbers. So if you want, you can just do it at every number all at once. And then you get a formula that you can use to calculate the slope of the curve at all of those points together. Okay, that formula is called the derivative. Okay, so let me write that down. The derivative is a formula that outputs the slope of a curve at any point. The derivative is a formula that outputs the slope of a curve at any point. Okay, so for this one, we're going to find the derivative. Okay, so instead of, we're still finding the slope of the curve, so we're still going to use one of those formulas, either the limit as x goes to a or the limit as h goes to 0, either one. Okay, so I've already done h goes to 0 today, so I'm going to use the x goes to a method for this problem, just to emphasize it doesn't matter. So this is the formula that will give you the slope of the curve. If we wanted to know the slope of the curve at 2, we'd put a 2 here, here, and here. If we wanted to know the slope of the curve at 7, we'd put a 7 in these 3 places. But we don't want to know the slope of the curve at a particular point. We want to know the slope of the curve at any point. So we're just going to leave this as A and calculate it. And then when we get to the end, we'll have a formula that'll tell us the slope of the curve at any point. Okay, so for this particular problem, f of x is x squared, right? And then this says plug a into f, so that's going to be a squared. Just like if you plugged 3 into f, it would be 3 squared. So that'll be a squared. And then on the bottom it just says x minus a. Okay, now we're going to factor x squared minus a squared. That's the difference of 2 squares. So that factors into x minus a times x plus a. So that's nice, because then the x minus a's cross out. And then we can use limit laws. We're going to take the limit of x and the limit of a. So it's the limit as x goes to a of x plus the limit as x goes to a of a. So I crossed these out and then did limit of that, limit of that. Just moved the limit past the plus, which is legal because it's a limit law that says I can do that. Okay, now these limits are a bit tricky because there's a lot of letters floating around. But remember, a is a number. We're trying to find the slope of the tangent line at a. So let's temporarily pretend that a is 2. So that's a 2 as well. So what's the limit of 2? Just 2, right? Or if a was 7, that would be the limit of 7, which would be 7. So since it's a number, the limit of a is just a. Okay, now this is a bit tougher. So let's, again, pretend a is 2. And let's picture a table in our head. This is the formula y equals x. So when you make a table, the y is always going to be the same as the x. So if that's 2, when you plug 1.9 in, it's going to spit out 1.9. When you plug 1.99 in, it's going to spit out 1.99. So those are getting close to 2. Or if a was 7, you'd plug 6.9 in and it would spit out 6.9. You'd plug 6.99 in, it would spit out 6.99. So those are getting close to 7. So this is getting close to a as well. And then a plus a is 2a. Okay, now this 2a is a big deal because this says if you want to know the slope of the curve at a, you just take 2 times the a value. So for example, if you wanted to know the slope of the curve at 7, it would be 14. Or if you wanted to know the slope of the curve at -1, it would be -2. So now for this particular curve, we have a formula that represents the slope of it at any point. And that's called the derivative. Okay, so this formula here is the derivative. So you could say f prime at a is 2a. I'm so used to this notation I forgot that I just throw it in there. So there's notation for the derivative. It's called f tick mark. So if you put a little tick mark above the f, then I messed up and I read it the way it's read. So f tick mark is called f prime. So the original f gives me the y values, right? It gives me the heights. But the f prime gives me the slopes. It's the derivative. And sometimes we just put an x there and call it f prime of x is 2x, because a just represents an x. Okay, so this is a big deal, because now I don't have to do, if it asks for the slope at 2, 7, and 9, I don't have to do that big whole process 3 times. I can just do the process once, and then plug 2 and 7 and 9 into this formula. It's time for the joke portion of the day. Did you hear that they're making coffins out of glass? I'm not sure if they're going to be successful. It remains to be seen. You know, like the remains of someone. If it's glass, then you can see. So the remains would be seen in the glass coffin. So, and then it remains to be seen if it'll be successful. Thanks for putting up with my jokes. My strategy is then you're happy when I start doing math again, because the jokes are so bad. Okay, let's see. So here's part B. If x is measured in seconds. So it's time. And y is measured in feet. So it's distance. What is the meaning of f prime of x? Okay, so f prime of x is the slope, right? Is it the average slope or the instantaneous slope? It's the instantaneous slope. So it has the limit on it, right? Without the limit, it's average, but with the limit, which is f prime, that's the instantaneous rate. Okay, so f prime is slope. So I've got a graph now that inputs time in seconds and outputs distance in feet. That's what this is saying. It's saying that the x is time in seconds and the output is distance in feet. And I calculated f prime, which is a slope. So if I find a slope on this graph, I would subtract two y's, right? So it would be a number of feet minus a number of feet. So that would be, the label on that would be feet, right? So the top of my slope would be measured in feet. And then if I take so many seconds minus so many other seconds, I just figure out how many seconds have gone by, right? So maybe 2 seconds to 6 seconds. When I subtract, then 4 seconds. So the bottom of my fraction would be labeled in seconds. So then the slope here is in feet per second. So we call that speed a lot of times. The official name for it is velocity. Okay, so we don't know necessarily whether this was time and feet, time and distance. But if it was time and distance, then the slope is the velocity. So what is the meaning of f prime of x? It is the instantaneous velocity. If we did an average rate of change, then it would be the average velocity. But since we did the instantaneous rate of change, since we did the derivative, then it's the instantaneous velocity. So average rate of change is a slope, and instantaneous rate of change is a slope. So they're both going to have the same label, and in this case, they're both velocity. But in the average case, it'll be the average velocity, and in the instantaneous case, it'll be the instantaneous velocity. What the instantaneous velocity means is you're in your car and you look at the speedometer, and that's what it says right then. It says maybe 30 miles an hour, right? That doesn't mean that you're necessarily going to go 30 miles in the next hour. It just means that right then you're going 30 miles an hour. That's instantaneous velocity. As opposed to average velocity would be you went 120 miles in 2 hours. So your average velocity was 60 miles an hour. Maybe you didn't go 60 the whole time. Maybe there was traffic and or you stopped at a light. So you didn't necessarily go 60 the whole time, but your average velocity was 60 miles per hour if you went 120 miles in 2 hours. So that's average rate of change as opposed to instantaneous rate of change. Okay, just a couple more notation things, and then we're pretty much done for today. So I talked about the fact that f prime of x was the formula that gives you the slope of the curve, right? So what do you think f prime of 1 represents? Yeah,
So
the slope of the curve at 1, exactly. And if I put a 7 there, it would mean the slope of the curve at 7. Without the tick mark, it means the height of the curve at 1, right? So what the y value is. But with the tick mark, it means the slope of the curve at 1. So that's the slope of the curve at 1. Okay, then there's another bit of notation. It's a d over a dx. And this is a command, like plus. So a plus sign tells you to do something. It says take the two numbers and add them together. Or a division sign is a command. It says take the two numbers and divide them. So this is a command. This tells you to do something. And this is the command, take the derivative. In other words, give me the derivative as your final answer. So in example 2, I gave you f of x equals x squared, right? And then I wrote out the sentence, take the derivative of f of x. I could have avoided all that language and just written d dx of x squared. So this would mean find a formula for the slope of the curve, and the curve I'm asking about is x squared. d dx means find a formula for the slope of the curve, but I can only do that if I know what the curve is. So then that tells me what the curve is. And what was the formula for the slope of the curve for x squared? It was 2x, right? So then I could say this answer is 2x. Because if I take the derivative of x squared, if I find the formula, then it comes out to 2x. And how did we find that formula again? Yes. Limit as x approaches a of f of x minus f of a all over x minus a, right? Or we could have chosen limit as h goes to 0 of f of a plus h minus f of a all over h. Doesn't matter which one we use. They're interchangeable. Okay, is everybody doing okay? Are you sure? All right, that's all I got. So you got 5 minutes to work on some stuff. Make sure you